This question is from Formative 8, Set Operations, Intersections, and Unions. The question is, draw two Venn diagrams to determine whether the following expression is equal for all sets A, B, and C. And so they give us this problem here. This is the first diagram that we're going to draw, and then this is the second Venn diagram that we're going to draw. There's two ways that you can approach this problem. And one way is for us to draw our Venn diagram here. So I'm going to label this A, B, and C. Next, what we can do is label the regions. So for example, this region, I'm going to call it 1. The intersection here, I'm going to call it 2. This region, I'm going to call it 3. This one, I'm going to call 4, 5, 6, 7, and everything on the outside, I'm going to call it 8. So what I want to do next is I want to write down what my set A is composed of. And here I can see that it's 1, 2, 4, and 5. So you can see here 1, 2, 4, and 5. Set B is composed of 2, 3, 5, and 6. And C is composed of 4, 5, 6, and 7. And the universal set is composed of everything. So 1, 2, 3, 4, 5, 6, 7, and 8. So what we can do next is we can figure out each part here. So I have A intersected with B, union C. So what I can do is, since I'm going to need the complement, I'm going to go ahead and find the complement. And the complement is all the numbers that the complement is all the numbers that are not part of A. So I have 1 here. So the complement is all the numbers that are not part of A but are in the universal set. So here I have 1. 1 is already there. 2 is there. 3 is not in A, so that's going to be part of my complement. 4 is there. 5 is there. And then I have 6, 7, and 8. So here I'm going to go ahead and write my A complement, which is 3, 6, 7, and 8. Then I have intersected with B. B is 2, 3, 5, and 6. So this is all that I have in my parentheses. Then I have union C, which is 4, 5, 6, and 7. So now I can work inside of my parentheses here. So I have this intersected with this. Remember, the symbol for intersection means what they have in common. So I have a 3 here. 3 is here. So that's going to be in what they have in common. 6 and 6. 7 is in this set, but it's not in the second set. And 8 is in this set, but it's not in this set. And the same with 5. So my intersection is 3, 6. So now I have union, and I'm going to go ahead and write it here, 4, 5, 6, and 7. So now the union means to put everything together. So we're going to have 3, 4, 5, 6, and 7. So this would be our answer for this first part. Now we need to check the second part. So the second part is this one here. So A complement intersected with C. So we're going to have A complement intersected with C, intersected with A complement intersected with B. So again, we can take each part and write it out. So for my first part, A complement is 3, 6, 7, and 8. And we got that from over here. Then I have my symbol for intersection. C is made up of 4, 5, 6, and 7. So that's in that parentheses. Then I'm going to have intersected with a complement again, which is 3, 6, 7, 8. Intersected with B. B is 2, 3, 5, 6. Okay, so now we can work each of the parentheses. So intersection again means what is this have in common with this? And so here we're going to have 3 is not in both, 6 is in common, 7 is in common, and that's it. And then we have this intersection symbol. And then this intersection is what does these two have in common? So we have 3, 6, and that's it. So now the intersection between these two is going to be 6. So what you want to compare is your result here and your result here. Are they the same set? And the answer is no. So we say that this is not equal. So this was one way to solve this problem. Another way is that you can draw out what each of these mean, but that usually seems a little bit more complicated. So let's try another example. So here we want to use a Venn diagram to shade the region that is expressed by this right here. So one of the things we can do is we can try to color it in by looking at it, or again, you can do what we did earlier. We can number these regions. So everything that's just an A is 1. This intersection, I'm going to call it a 2. This would be 3. This would be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so I'm going to go ahead and write out the sets. So A is 1, 2, 4, 5, 8, 9, 12, and 13. And then B is 2, 3, 5, 6, 9, 10, 13, and 14. And C is 7, 11, 6, 10, 5, 9, 4, and 8. And D is 11, 15, 10, 14, 9, 13, 8, and 12. And the universal set is everything. 12, 13, 14, 15, and 16. So now we can take our information A union B complement intersected with C intersected with D. So here I'm going to write A, and I'm going to write B, and then the complement intersected with C, intersected with D, So the union means to put everything together. So all of this and all of this. So we're going to have 1, 2, 3, 4, 5, 6, 8, 9, 10, 12, 13, and 14. Then here we want to take the intersection of these two. So what do they have in common? 7, no, 11, 6, no, 10, 5, no, 9, 4, no, 8. So now the complement of this is everything that's not in there that is in the universal set. So here we have 1, 2, 3, 4, 5, 6. So 7 is missing. 8, 9, 10, 11 is missing. 12, 13, 14, 15, and 16. So now we take the intersection. So what do they have in common? 11. And that's it. So your answer is to shade only this part here. So in your WebAssign assignment, you would look for that result, which is letter C.